Hello students, today we are starting a new chapter, that is the chapter number 10 in the second textbook. The name of the chapter is the SBlock elements. As we have already learned the periodic table in which different blocks are there, that is S, P, D and F block elements. So here in this chapter we will be going to learn the details of S block elements. What is S block elements? The elements of the periodic table in which the last electron enters in the s orbital, that is the outermost s orbital, that elements are called as S-block element. As the S block can accommodate only 2 electrons, therefore only 2 groups are belonging to S block of the periodic table. That is a group 1 which is called as alkali metals, group 2 that is called as alkaline earth metals. In the group 1, the elements are lithium, sodium, potassium, rubidium, cesium and francium. They are collectively known as alkali metals because these are called as alkali metals because they can form hydroxides on the reaction with water which are strongly alkaline in nature. That's why they are collectively called as alkali metals. In the group second, the elements are beryllium, magnesium, calcium, strontium, barium, radium. The elements of group 2, which is collectively called as alkaline earth metals. These metals, with the exception of beryllium, are commonly called as alkaline earth metal because these are called as alkaline earth metals because their oxides and hydroxides are alkaline in nature, and these metal oxides are found in the earth crust. So we need to discuss the details of these elements, that is group 1 element alkali metals and group 2 element that is alkaline earth metal. In group 1 and 2, lithium and beryllium are the first element in the group 1 and group 2 respectively. They exhibit a similar property to its own member, like lithium shows similarity with its own members. Similarly, beryllium shows similarity with its own members. But there are some properties which is called as anomalous properties in which the first member of the group shows dissimilarity to its own member, but it shows similarity to its diagonal element. That we have already learnt, that is the anomalous properties of second period elements, in which the second period element, that is the member that is called as the first element in that respective period, it shows similarity to its diagonal element. That is, in this case, lithium shows similarity to the magnesium, beryllium shows similarity to aluminium, boron shows similarity to silicon, and carbon shows similarity to phosphorus. So here the first member of each group shows similarity to its diagonal element, that is of the respective group. So in these anomalous properties, this type of resemblance, it having a relationship that is called as diagonal relationship. So the second period elements, that is the first member of the respective group, shows similarity to its diagonal element. Such relationship is called as diagonal relationship. This type of diagonal similarity is commonly referred as a diagonal relationship in the periodic table, that we have already discussed about the diagonal relationship. The diagonal relationship is due to the following reason. These are smaller size of the atom, that is the first member is smaller in size respect to its own members in the group, and of high ionization enthalpy because of the non-availability of d orbitals. So these three important points are which makes the first member differ from its own group members, and but it shows similarity to the its diagonal element. So the relationship is due to the smaller size of the atom, that is due to the similarity in the ionic sizes, that is a diagonal element shows similarity in their ionic sizes in the charge by radius ratio of the elements. So here in this chapter we will be going to discuss such anomalous properties also. So the group 1 element will be going to discuss in detail. The members of this group are lithium, sodium, potassium, rubidium and cesium. Here these elements we need to learn the sequence. So it is very important to learn the sequence, that is top to bottom it is necessary to learn the sequence. That is first member is the lithium, then sodium, potassium, rubidium, cesium, francium. So it is compulsory, all have to learn the sequence, that is top to bottom. You have to learn the sequence for the group 1 and group 2. Next we are going to study the general properties of alkali metals, that is a group 1 elements. First let us talk about the electronic configuration. When we write the electronic configuration for these elements, it is very clear from this that they have similar pattern of electronic configuration, in which the last electron is in the s orbital, that you can see here in lithium. The last electron is in 2s, in sodium it is in 3s, in potassium it is in 4s, then 5s, 6s, 7s. So that means here why these elements are belong to S block, because the outermost electron, or we can say the last electron, is in the s orbital in the outermost shell. So better we can write the general electronic configuration for these element as NS1, where N is representing the principal quantum number, or we can say it represents the period in the case of periodic table. So if the outermost electron is in 2s1, that means here n is equal to 2. So we can write 2s1 when you compare with this general formula. What is n? N is equal to 2. So that means this element is belonging to the second period. Here the element potassium, in which the outermost electron is in the 4s orbital. So 4s1 when you compare with the electronic configuration, general electronic configuration, so what will be n here? N is equal to 4. That means this member is the member of period 4th. So in this way the elements are arranged in the periodic table. So the general electronic configuration for these elements is NS1. Next is a property, that is ionization enthalpy. The ionization enthalpy of alkali metals are considerably low and decreases down the group, that is from lithium to cesium. Ionization enthalpy for these decreases top to bottom. Why it is decreases? Because the size is increasing top to bottom. When we go top to bottom, what is the size is increasing. Size is increasing, so we can say that the ionization enthalpy is decreases. Because what is the relation we have already learned for the size and ionization enthalpy? That is, greater the size, lesser will be the ionization enthalpy. So that means top to bottom, what is actually happening here? The size is increasing. Therefore, ionization enthalpy is decreases. So here increasing nuclear charge and the outermost electron is very well screened from the nuclear charge. That also one of the reason for this. That is, first reason is increasing size from top to bottom and increasing the nuclear charge. Therefore, the outermost electron is very well screened from the nuclear charge. So this is what about the ionization enthalpy. Next is the hydration enthalpy. The hydration enthalpy of alkali metal ions decreases with the increasing ionizing sizes. That means when we compare the size of these, we can say that which one will be the greater size, because top to bottom size is increasing. So greatest size will be for the cesium ion. But the hydration enthalpy of alkali metal decreases with the increase in the ionic size. That means cesium ion have the greatest ionic size, but it have the lowest hydration enthalpy. So hydration enthalpy, we can say that it decreases with the increasing ionic sizes. Next, we need to discuss some of the physical properties of alkali metals. That is, all alkali metals are silvery white, soft and light metals. That is a physical appearance of alkali metals. They are usually silvery white, soft and the light metals. Lightweight metals are the first group elements. Because of the larger size, these elements have low density, which increases down the group from lithium to cesium. They have low density, they have low melting point and boiling point. From among these elements, potassium is the lighter here than the sodium. Here the melting point and the boiling point of the alkali metals are low, indicating the weak metallic bond due to the presence of only single valence electron in them. When we make the electronic configuration, it is very clear that only single electron is there in the valence shell. So because of this reason, they have very weak metallic bonding. Because of this only, they have very low melting point and boiling point. The next important point are they are electropositive in nature, because they always form positive oxidation state. As we are familiar with the sodium is always forming a +1 charge, potassium +1 charge, rubidium +1 charge. So they are electropositive in nature. They have a greater tendency to donate the electron in order to get stabilized. So that we have already learnt in the lower classes also. Next property, that is metallic character. These elements shows the metallic characters. Next is the oxidation state. Oxidation state of these element is +1. As we know that sodium can form +1 oxidation state. Lithium, sodium, potassium, it can form +1 oxidation state. Therefore, the oxidation state for these elements are always +1 oxidation state. Next is the photoelectric effect that we have already learnt in the chapter structure of atom. That is the ejection of electron from the metal surface when the light of suitable frequency strikes on it. So such effect is takes place when the metal like potassium, rubidium, cesium, these elements in which the light of suitable frequency strikes on it, electron get ejected. That is called as photoelectric effect. So these elements shows photoelectric effect. Next is the very most important identification test for these elements, that is the characteristic flame coloration. That is a flame test. Alkali metals and their salts imparts characteristic color to the oxidizing flame. That is, when we do the flame test, there will be a characteristic coloration like lithium, crimson red color. For the case of sodium, yellowish color, potassium, violet color, rubidium, red violet, cesium, blue coloration. So there will be a characteristic coloration is given by these metals or their salts with the flame. Therefore, it is called as a flame test. Why it gives a flame test? Because it have only single electron in the outermost shell, which get easily excited to the higher energy level. That we have learnt in the chapter structure of atom. That is the electron from the ground state, it absorbs the energy and get excited to the higher energy level or higher energy state, that we can write excited state, and when it come back to the ground state, it emits a radiation, and the emitted radiation, that is actually the radiation from the visible region. So here the two processes is taking place, that is excitation and then the transition. That means the coming back to its ground state is called as transition state. So when it come back to the ground state, it emits the radiation in the visible region. Therefore, it gives a particle coloration. That is the coloration which is shown here. So this is one of the identification tests for these elements and their salts also. So in this video, we have discussed about the general properties of SBlock element and the physical properties for the group 1 element, that is alkali metals. In the further videos, we'll be discussing the details of SBlock element. So this is all about this video. Have a nice day.